Hi everybody, welcome to another video in Business Calculus section 9.2, Infinite Limits and Limits at Infinity. So clearly in this section we have two parts. The first one is infinite limits and the second one is limits at infinity. So infinite limits is where the limit equal to infinity plus or minus infinity, and we will have the vertical asymptote to go with that. First, let's look at the first example. Consider the following function and its graph. So the graph of the function 1 over x minus 1 look like this. Now let's find the limit when x go to 1 from the left hand side of 1. So when x go to 1 from the left side, we see that the function y values keep getting smaller and smaller, and essentially we write go to negative infinity. And then we take a look at the limit of the same function, but go to 1 from the right hand side. On the right hand side, if we go along the graph, the function just keep getting higher and higher. So we say the limit equal to infinity. Because the left-handed limit and the right-handed limit do not agree, we will say that the limit when x go to 1 does not exist. Right, so pretty much just the limit of the function, but this time the limit is equal to infinity. Right, next we define the vertical asymptotes. The vertical line x equal to a constant a. So the vertical line, the equation is x equal to something. For the graph, if we have the function go to infinity or negative infinity as x go to a from the left side on the right side. So it doesn't matter, we only need to go the function to go to infinity or negative infinity, where x go to negative a from the left side or from the right side. So from the previous example, the vertical asymptote is this line. X equal to 1. Because when x go to 1 from the left side or from the right side, the function either go to infinity or negative infinity. We only need one side to have the vertical asymptote. Right, so that's how we define the vertical asymptote. Now, how do we find it? To find the vertical asymptote for the rational function, the rational function is the numerator over the denominator. To find the vertical asymptote, we let the denominator equal to 0 and the numerator not equal to 0. In that case, whatever the values we have is the vertical asymptote. So loosely speaking, we just say the bottom equal to 0, but the top is not. Right, so we say the bottom equal to 0 and the top is not equal to 0. We need both of them. Right. The reason we need the bottom equal to 0 because the function when divided by 0 is undefined. As you see, where there's the vertical asymptote, the function is undefined. So that's why we want the bottom equal to 0, so the function is undefined. And we do need the top equal to 0 as well, because 0 over 0 is indeterminate. So we will talk about the case where the bottom and the top equal to 0 later. To say if to find the vertical asymptote, we let the bottom equal to 0 and the top is not. If the bottom equal to 0 and the top equal to 0, and then we will have something else, which we'll discuss later. Now let's look at this example. Find the vertical asymptote of the following function. Right, so we have this, and simple, we just let the bottom equal to 0 and substitute into the top and make sure it is not equal to 0. Right, so what we need is for the vertical asymptote is the bottom equal to 0. Right, so we start with x squared minus 1 equal to 0, and we can plus 1 on both sides. So we have x squared equal to 1. Now, x squared equal to 1, obviously x is equal to 1, but that's not all of it. You will see this many times, so make sure that when we have the square equal to something, to get rid of the square, this is a plus or minus. This, we say x equal to plus or minus, don't forget that square root of 1. Square root of 1 is 1, so if x equal to plus or minus 1. So we found the values of x that make the denominator equal to 0, that make the bottom equal to 0. Now we substitute into the top and make sure it is not equal to 0. We don't have to solve for it, we just have those values, and we say when x equal to 1, when x equal to 1, the top equal to, we're going to put 1 into x, and that equal to 0. Well, the vertical asymptote, the bottom is 0 and the top is not. Since this is equal to 0, this is not a vertical asymptote. Then we test for the other values. When x equal to -1, the top equal to -1 square plus -1 minus 2. So that minus 3 plus 1 is minus 2. Right, and that is not equal to 0, which is good. So we have the vertical asymptote of x equal to -1. So the vertical asymptote is x equal to -1. So a few things need to remember is when we solve for something square equal to a number, we're going to don't forget the plus or minus sign. And for the vertical asymptote, the bottom is 0, the top is not. Right, let's graph, see what happened. Right, we have the function of x squared plus x minus 2 divided by x squared minus 1. And we look at the graph. Right, and you see when x equal to 1, there's nothing here, but actually there's something. When x equal to 1, it's undefined, so the graph here is incorrect. There should be a hole in here. And indeed we have the vertical asymptote of x equal to -1 here. So the answer is correct. And we said when x equal to 1, I'm just gonna sketch a graph real quick here. So we have the graph. And when x equal to 1, there is a hole because it's undefined. So if the bottom equal to 0 and the top equal to 0, it is not a vertical asymptote, but it is a hole. It is missing a point on the graph. Right, let's look at another example. Find the vertical asymptote of this function. Well, just need the bottom equal to 0 and the top is not. So legally x equal to 3. And then we substitute into the top. I will say at x equal to 3, the top equal to 3 squared minus 4 times 3 plus 3. That's 9. 12 minus 12 is 0. So if it is 0, this is not a vertical asymptote. So the graph of this, this has no vertical asymptote. Because there's no other values that we will test for other than x equal to 3. So in this case, no vertical asymptote. Right. This one, I put at the bottom equal to 0. Have x squared plus 1 equal to 0. Subtract 1 on both sides. We have x squared equal to -1. And check the square root on both sides. And don't forget, when we do that, have plus or minus. What we see here is there is a negative inside a square root. So that will give us imaginary. Which is not a real number. So in that case, there is no vertical asymptote. Remember, vertical asymptote is on the graph, and the graph only have real values on that coordinate system of xy coordinate system. So there is no imaginary in there. So in this case, we say there's no vertical asymptote. Right. So the bottom equal to 0, and make sure the top is not. So solve for the bottom equal to 0, and then check whatever values that make the top not equal to 0. That will be the vertical asymptote. Right. Now, what in terms of limits, what do we have? Remember, I think I write that on the previous section, that if we have 0 over something else other than 0 is equal to 0. If we have something other than 0 divided by 0, then that is undefined. And undefined including infinity or negative infinity. By the way, infinity and negative infinity are not really numbers, so that those considered to be undefined. In this case, undefined, including plus or minus infinity. Right. Right. When we have 0 over 0, that will be indeterminate. If we talk about limit, or if we talk about the graph, it will be a whole. So all of this we're talking about the limits. Not in terms of function in general. We'll talk about limit. Limit of something that go to 0 over 0, that indeterminate. Right. Now, let's see if we try to find the limit of something like this. Well, of course, when we're trying to find the limit, just going to put the numbers in, see what happens. That's the first thing we do, right? And where there's a superscript, we just ignore it. We're just going to substitute in 1 from the left side, from the right side. Does not matter. So we substitute 1 in top. So we have -1 over 0. Well, of course, this is undefined, but we know that it's undefined. It could be positive or negative infinity. So let's think about this. If we have 1 from the left side, right? So on the left side of 1, if we talk about left side here, it's going to be 0.99999, very close to 1, but not equal to 1. Very close to 1, but less than 1. So we say, let's say we have 0.000, sorry, close to 1, 0.9999, so that's close to 1 on the left side, right? And we just evaluate, and we subtract 1, and we square it. It's going to be a very small number. 1 times 10 to the negative 12. It's a very small number. It's still 0, but it's going to be positive if it goes from this side. So when we find a one-sided limit, something else over 0, we have to test to see if it is a positive or negative, because negative divided by positive is negative. So we say limit of x goes to 1 from the left side of x minus 2 over x minus 1 square is equal to negative infinity. Right? We know negative 1 over 0 is undefined, but we don't know for one-sided limit. It could be positive, it could be negative. In this particular, it's positive. So that's what we have. Right, next. When x equal to 1, again, this is 1 minus 2. Again, we have negative 1 over 0. Also, this is one-sided limit. We have to know what happened. Is that it is 0, go to 0, but is that going to be a positive number or negative number? So something greater than 1, I would say 1.0001, like this. I can just hit the star button and then hit x, and I just say, how about x minus 1 square, and it's going to be, once again, it's a positive. So from one-sided limit, we find out that it goes to 0, but from the positive sign, meaning it's going to be positive, and negative divided by positive is negative. So the limit as x go to 1 from the right side of x minus 2 xy minus 1 square is equal to negative infinity. Now the right-handed limit equal to negative infinity, the left-handed limit also negative infinity. So we say when x go to 1, it go to negative infinity. Right, so it's only the case where we have something other than 0 divided by 0, it is undefined. But if we're talking about one-sided limit, it could be positive infinity or it could be negative infinity. We have to find out by putting a very small number into it. Of course, if we have the number going from this side, it's going to be 1.00001, something like that. Now we go to the second part of the section, limits at infinity. So that is what happened to the function when x goes to infinity. So the first part is the infinite limit where the function goes to infinity, the y value goes to infinity. This is where the x goes to infinity. So we write x go to infinity to indicate that x is increasing without bound, and x go to negative infinity to indicate that x is decreasing without bound. On this one, we focus on the horizontal asymptote, and then we talk about the limit. Horizontal asymptote. The line y equal to b is a horizontal asymptote of the graph if the function go to that values when x go to infinity or negative infinity. Now if we look at the first problem, we see that when x go to infinity or negative infinity, the y values go to 0. So in this example, we have the horizontal asymptote of y equal to 0. Because when x go to negative infinity or positive infinity, the y values go to 0. So y equal to 0 is a horizontal asymptote. Right. We'll talk about how to find the horizontal asymptote later, but it is a horizontal line is where the function approaching to where x goes to infinity or negative infinity. Now, if p is a positive real number and k is any real number except for 0, then we have that. So, that's complicated. I want to just summarize is this. If we have something other than 0, a constant, divided by something that go to infinity, so finite divided by infinity go to 0, and then the other way is that. So I will write the summary as like this. If we have something finite, of course finite is not infinity, and divide by something that is plus or minus infinity, that will be equal to 0. Then we have plus or minus infinity divided by something that is finite. Well, if you take infinity divided by 2, we still have infinity, right? So we have infinity divided by finite. It's going to be plus or minus infinity. I'm just going to keep the plus or minus because sometimes we have the positive divided by negative or negative divided by positive and so on. And they'll say, what happened if we have a plus or minus infinity over plus or minus infinity? Well, that is also another case of indeterminate. Right? Now, how do we find the limit? And subsequently, how do we find the horizontal asymptote? So if we, now we just focus on the asymptote or the limits of the rational function. So when we have a polynomial divided by another polynomial, and this is the long way to say that when we have a polynomial and x go to positive or negative infinity, it doesn't matter. Only the highest power term matter. To summarize all of this, I would say as x goes to infinity or negative infinity, only the one with the highest power term matter. And after that, we simplify. You see how it goes. Alright, now let's just find the limit first, and then we find the horizontal asymptote. Alright, so the limit, we have a polynomial here, right? The one with the highest power term matter. So this is equal to limit as x goes to infinity to x cubed. Now we're going to put infinity into x and cube it. Well, infinity times infinity times infinity is still infinity, but it's going to be positive, right? So in this case, it is just positive infinity. It's positive. Right, on this one, as x go to negative infinity, the polynomial like this, only the one with the highest power term matter. So I just take the highest power term. And then substitute in the limit, see what happens. This time we can just say equal to, because we can get something from it. Right, negative infinity square, negative times negative, negative times negative is positive. So this is going to be positive infinity times a negative 5. So this is going to be negative infinity. Right, so to only take the highest power term. And look at this. So for this, we just take the highest power term on the top, 3x squared, highest power term at the bottom, 2x squared, and we cancel out x squared and x squared. We have 3 over 2, so that will be the limit. Right? So as x goes to infinity or negative infinity, only the highest power term matters. Right? So let's take a look at this. Once again, the highest power term matters. To x squared, x cubed. Right. For this, we can simplify the x squared and x squared on the top and x squared at the bottom. Is there 2 x squared on the top? Just cancel out. There are 3 at the bottom. When we cancel that, we still have 1 left. So we end up with limit as x goes to negative infinity of 2 over x. Now, since x goes to negative infinity, if we write 2 over negative infinity, this is the case where we have a finite number divided by infinity. So we have a small amount. The more we divide by, the less we have. Right? The less the quotient is. So in that case, let's say we have $2 divided by 10 people. How about we divide by 1,000 people? The more we divide by each, we get less and less. So in this case, that equal to 0. Right, so the limit equal to 0 because we have finite divided by infinity. Right, so just take the highest power term. That would be simple, right? Once again, the highest power term, x squared over 2x. There's 1x at the bottom, we cancel with 1x on the top. So the top we just have an x. And we just have x divided by 2. Right? Now infinity is the limit for when x goes 2. So we put infinity into x divided by 2. If we have infinity divided by 2, it's still infinity. So that will be the limit. Right? Simple enough. Take the highest power term and then simplify. See what happened after that. And when we have that, when y equal to it is going to be the horizontal asymptote. So very easy. We just find the limit at x go to infinity or negative infinity. Right? So the horizontal asymptote is when x go to infinity or when x go to negative infinity. We have to consider both of them. So let's look at for this one we're trying to find the horizontal asymptote. So take that function as x goes to infinity. We talk about positive infinity first, and we talk about negative infinity after that. We need to do both. Right, so that cancels out. We have the highest power term. Negative 2 x cubed, 5x cubed, that is the highest term. And this cancels out x cubed and x cubed. We just have negative 2 over 5. That's a constant, so that will be just negative 2 over 5. Because we find the limit, so we say that is the horizontal asymptote. Right. We still need to check when x goes to negative infinity. Take the highest power term. So this is the same thing. Cancel out the x cubed and equal to negative 2 over 5. So which is the same. So that's still the horizontal asymptote. Right, next on this one. When x go to infinity of the function and we take the highest power term, not the first term. So in this case, this is 3x squared over 2x squared. Right, that cancel out, just 3/2. So we have the horizontal asymptote y equal to 3/2. Of course, in this case, it doesn't really matter if it go to positive or negative infinity, but we still do that. Once again, we take the highest power term and that's the same thing, same horizontal asymptote. Right, for this one we take the limit as x goes to infinity, x cubed plus x minus 2 over 2x minus 3. When x goes to infinity, only the highest power term matters. So we just have x cubed over 2x. We'll cancel 1x at the bottom. There's 3 on the top, so there's cancel 1 of them out. We have 2 left. So that gives us x squared over 2. Now x is infinity. X go to infinity divided by 2, so that still is infinity. Right. And then we test for negative infinity. Once again, the highest power term matter. Simply find that out. We have x squared divided by 2. Again, this time it is negative infinity though. Negative square is going to be positive. Divided by 2 is still positive infinity. Right, so because infinity is not really a number, so in this case we say no horizontal asymptote. Because it is, we don't have the constant. That is the limit of the function when x goes to infinity or negative infinity. I think we need one more example. Right, so we have that. So we find the limit at x goes to infinity of 2x plus 1 over x squared minus 3x. So that cancel, take the highest power term, we have 2x over x squared, and then cancel 1x on the top, and x squared at the bottom. There are two of them, cancel one of them. We have just 2 over x. Now, x go to infinity. If we have 2 divided by infinity, we have a finite divided by infinity, so that is equal to 0. So the horizontal symptom is y equal to 0. Yeah, so to find the horizontal symptom, I'll just find the limit as x go to infinity and x go to negative infinity. Now when x go to negative infinity, negative infinity, right? Once again, take the highest power term. And 1x cancel out. Now x go to negative infinity. Well, we still have finite number 2 divided by negative infinity, so that is equal to 0. So the horizontal symptom, again, is also y equal to 0, which we already have, so we don't need to write that again. Right, so simple enough. To find the horizontal symptom, we let just take the highest power on the top, the highest power on the bottom, find the limit when x go to infinity or negative infinity. And then we said, do we have to do both? The answer is, in general, yes, we have to do both of them, because we might have maximum of 2 horizontal symptoms, one when x go to infinity and one for x go to negative infinity. I'll give you an example where we have 2 horizontal symptoms. For example, we may have like absolute value of x, absolute values of x, just divide by x plus 1, for example. Simple enough, right? Divide, sorry. You see, there is a horizontal symptom that is equal to 1 on when x go to infinity, and when x go to negative infinity, it go to negative 1. So in this case, we have 2 horizontal symptoms, right? 1 when x go to 1, and 1 when x go to 1 is y equal to 1 when x go to infinity, and the other horizontal symptom is y equal to negative 1 when x go to negative infinity. So we have maximum of 2 horizontal symptoms, 1 for infinity and 1 for negative infinity. As for vertical symptom, how many we may have? The answer is infinite. We may have a bunch of vertical symptoms. So it doesn't matter, we might have something like this, and there will be a bunch of vertical symptoms. And to find a vertical symptom, the bottom equal to 0, the top is not, because if both of them equal to 0, we have a hole. And that's all I want to cover in this section. As always, thank you for watching, and see you in another video of business calculus.